Hello everyone, I am Dr. Subhasish Saha, Assistant Professor in Physics, Department of HNS, MLR Institute of Technology, Hyderabad. Today in lecture 2 of Crystallography and Materials Characterization. So today is already last week, so we discussed what is crystallography, what is the crystal structures, what are the basic things are there, bases, then lattice points or space lattice, then what was the idea about lattice parameters, then unit cell, several types of crystal systems is there. That was discussed in the last lecture, and today's I'll discuss about little bit advance of this topic. So overview of today's topic is crystal systems, effective numbers of atoms in unit cell, per unit cell, then atomic radius, atomic packing fraction, coordination numbers. So these are the total today's idea. So crystal systems, I already discussed, there are total 7 systems is there, but in those cases there are mostly found crystal structure is simple cubic, body center cubic, face center cubic and hexagonal close pack structure. Now come to those are the most fundamental structures. So this is center cubic, body center cubic already discussed. At the body there is one atom is there, face center, all corner atoms are there, as well as on the each and every face atoms are there, and hexagonous is it is also showing these things. So these are the mostly found crystal systems. Now come to the effective numbers of atoms per unit cell. So we already discussed about what is unit cell. It is a fundamental building block of a crystal structures. If we repeat those things in all directions, we will get the entire crystal structure. This is a unit cell or is a simple cubic structure. Now in simple cubic structure there are 8 corner atoms are there, and these 8 atoms are shared by the nearest or consecutive 8 cubes. That's why each atoms are shared by the 8 cubes. So effective numbers of atoms in simple cubic is 1, because these atoms, suppose there are 8 consecutive cubes are there, which is so that is shared by the another 8 cubes. So effective numbers of atoms is 1 in case of simple cubic. In case of body center cubic, the similar thing is there. There are 8 corner atoms are there. Suppose that 8 corners atoms are shared by the 8 consecutive. That one atoms is shared by the 8 consecutive or cubes. So the overall effective numbers of atoms for these corner atoms is 1. Another, there is one extra atoms is there which is seated or floating at the middle or at the center of the body center cubic. So total effective numbers of atoms is 2. Now in case of face center cubic, so this is the structure of the face center cubic. These are some like snapshot of this inner diagram. So 8 corner atoms is there. So one atom is occupied or shared by the 8 consecutive crystals. So that is effective numbers of atoms is 1, and there are atoms are there on each face. Okay, so this plane is shared by the 2 consecutive cube. So there is, suppose there is another cube is there this side. So this is common for 2 consecutive cubes. So these atoms is shared by the 2 cube. So that's why in similar way there are total 6 face atoms are there. So total face 6 atoms are there, and each plane is shared by 2 consecutive cubes. That's why it is half into 6. So that gives you 3. So total effective numbers of atoms is 4. So this means in this case how it's got 4 atoms we got. So there is 8 corner atoms, that is 1 gives you, and it is why it is 1 by 2 into 6. There are 6 phase atoms and each phase is shared by 2 consecutive cubes. That's why it is 1 by 2 into 6. So total is 4. These are effective numbers of atoms per unit shell for 3 different types. Now come to the what is primitive shell. In case of primitive shell means which unit cell contain only 1 atoms. Effective numbers of atoms is 1. That unit shell is called primitive unit cell. Consists only 1 atom. Example is simple cubic. And if a shell which is contain more than 1 atoms, that is non-primitive shell. Example is BCC and FCC. Now coming to the atomic radius. What is atomic radius? Atomic radius is define a half distance between the nearest neighbors in a crystal. Basically So there are 8 corner atoms are there, right? So if we talking, it is considered, or you can imagine there are 8 sphere, okay, and those one sphere is touched with the another sphere. Looking this diagram, one sphere is touched with the another sphere. So each and every sphere radius is r. Okay, now so total distance between one center of the sphere to another center of the sphere. So center to center, the total distance is 2r basically. This means because one sphere radius is r, another one is this. So the distance between two consecutive center of two sphere is 2r. Now in case of simple cubic, ABC are equal. So suppose this distance is a, so we can say AR equals to 2r equals to a. So r equals to a by 2. This is the atomic radius for simple cubic. Next, in case of body center cubic, we know the diagram a little bit different. Now we have to little bit think about these things. This we have to imagine. So body center cubic, there are 8 corner atoms is there. Suppose this is a room. In this room, there are 8 corner atoms are there, and along with that, one center atoms is there. Now we have to find the distance from one corner atom to this. What is the center atom is there, which is floating. So how to determine the distance between these things, two atoms? One is corner atom and one of this center of this center atom. This one, body center one this to this. So we have to find the distance these to these. So this is not in the same plane. First we need to take a distance for what is the distance. Suppose in my floor, in the ground, in the floor, suppose what is the distance, diagonal distance. For that we have to take a triangle. So suppose this is ABF. This is a triangle. This is on the plane, on the bottom plane. Suppose. So what is the distance? We have to figure it out. Suppose in triangle ABF, we know that AF square equals to AB square plus BF square. So AB is distance is A and BF is also A. So we can say that AF square equals to 2A square. So that is the distance, diagonal distance on the floor. Now what is another triangle? Suppose from there is another, first we have to find the distance on the floor. There is suppose two things. Okay, that distance we have figured it out from ABF. This is the thing. Now another point is, now another atom is there which is floating on the middle. So how can we determine that distance? Now we have to take that another triangle A, F and H. We know, we already got what is AF. AF square is equals to 2A square, and what is FH? FH is A square. FH square. From this triangle AFH, we know that AH square equals to AF square plus FH square. So AF square already got 2A square and FH square is A square, and this AH is basically 4R. Why 4R? Because these two, this is R, this two, this is another R, and this is 2R. Similarly, this is also R of the sphere, another is R. So total 4R. So 4R square equals to means 4R square equals to 3A square. So this is basically 16R square equals to 3A square. So R will be root 3A by 4. This is for BCC. If we little bit understand the diagram, then it is very easy to imagine these things. Now next come to this is the atomic radius for body center cubic. Now for FCC, FCC is much easier because there is a distance between one corner atom to one phase atom, on any plane. That is the distance or radius between two sphere. Now what is this, how to do these things? Suppose there is a simplest one is, so there are corner atoms, okay, on a single plane. Suppose on a plane there is one phase atom. Now we know this is R, this to this is R, 2R. Similarly, this is also 2R, total 4R. So from triangle ABC, this triangle ABC, from this triangle we can get that AC square equals to AB square plus BC square. So 4R whole square equals to A square plus A square. So this is R will come A by 2 root 2. This is for face center cubic. This is the atomic radius. Now, why you determine this atomic radius? Because with next discussion is our packing fraction, atomic packing factor or atomic packing fraction. Now, what is atomic packing factor? Atomic packing factor is what is the volume occupied by the atoms in a unit cell divided by the volume of the entire unit cell. Suppose in a unit cell, okay, how many atoms are there? That is depends upon the crystal structure, which type of crystal is there. It is SCC, BCC or FCC. So that's what is the effective numbers of atoms. So suppose there are 1 atoms in case of simple cubic, effective numbers of what is the volume occupied by these atoms in the unit cell divided by entire volume of that unit cell. Now this is called atomic packing factor or packing density. Now next is, so in case of simple cubic. In case of simple cubic, what is the effective numbers of atoms? Effective numbers of atoms is 1. And what is the atomic radius? We already discussed, that is a by 2. Now then the volume occupied by these atoms is 4 by 3 pi r cube. Volume occupied by that atoms. Now a volume of the entire unit cell is a cube because each length is a. So unit cell volume is a cube and there is 1 effective atoms. So volume occupied by that atom is 4 by 3 pi r cube. So atomic packing factors is numbers of atoms, volume of that volume occupied by that atoms divided by total volume of that unit cell. So effective numbers of atoms is 1, volume of that atom is 4 by 3 pi r cube and a cube is the volume of the unit cell. Now r is basically a by 2 in case of simple cubic. So we can get the packing fraction is 0.52 or 52% in case of percentage. Now in case of body center cubic, similar things. In case of body center, what is the effective numbers of atoms? That is 2. Volume occupied by the atoms is 4 by 3 pi r cube. Now what is atomic radius is needed to determine what is r, that is root 3 a by 4 and volume of the unit cell is a cube. Now you substitute all those things in this formula, in these definitions. So it will come 0.68 or 68%. In case of face center cubic, similarly effective numbers of atoms is 4, volume of that atoms is that one 4 by 3 pi r cube. What is r? R is root 2 a by 4 and volume of the unit cell is a cube. If you substitute all those values, we will got 74%. 74%. Or now what is the physical significance of atomic packing factor? Atomic packing factor means how many atoms are closely packed in the crystal in a unit cell. So if there is more closely packed, then the atomic packing factor will be more. So in case of face cubic, that is 74%. In case of BCC, that is 68%. And in case of simple cubic, that is 52%. So FCC packing factor is more than BCC and BCC's packing factor is more than SCC. So it is more closely packed compared to BCC and BCC is more closely packed compared to simple cubic. So this is the concept of atomic packing factor. Next topic is coordination numbers. Coordination numbers is nearest numbers of atoms, okay, directly surrounding a given atom. So what is the nearest numbers of atoms? That is number which is called coordination number. Let's see if it will easily get the idea from the diagram. So suppose this is a crystal structure in case of simple cubic. So how many atoms are there in a, suppose there is one corner atoms, this black one of this cube. So this black one is one corner atom. How many closest atoms is there? Closest means that is all the distance are same. These distance all are same distance, okay. So if for simple cubic all our distance is a. So how many nearest numbers of atoms is there? There is 6 in case of simple cubic. These are the red marks are nearest neighbor atoms and what is the distance, or that is a. A is the distance. Now come to the body center cubic. In case of body center cubic, how many atoms are there? So this is a body center cubic atoms. From there all total 8 atoms are nearest neighbors, all are same distance, and that distance is root 3 a by 2 all. So total coordination numbers for BCC is 8. Now in case of FCC, if you a little bit idea about these things, there are two blocks. There are suppose two FCC building blocks are there. So suppose this is a common plane for two cubes. So this on the common plane there is one atom is there. Now from that atoms, how many closest atoms is there? So there are suppose there are 4 walls is there. So these 4 atoms are there, and similarly there are 4 corner atoms is there are 4 side wall on the top cube, top cube 1 2 3, and another is this one, and there are 4 on that plane. There are 4 corner atoms is there 1 2 3 4. So this top floor 4 corner atoms on that plane 4, and the bottom cube there are another 4 wall is there, 4 side wall. So there is 4. So total coordination numbers for FCC is 12, and the distance between these two consecutive atoms are from this black to any corner atoms or any side wall atoms is a by root 2. So I hope it is clear from this diagram. Again I am just discussing one more time. So there are suppose there is a two cube face FCC structure. So there is a common plane. This is a common plane between two block, and this is a one of the face black one is the one of the common atoms on the face between two block. Now from these, how many side wall atom is there for the top wall or top block? There are 4 side, 1, then 2, 3, 4. There are 4 side wall and corresponding 4 atoms is there. Now this is 4 atoms, this is 4. Next on this plane there are 4 corner atoms is there 1 2 3 4. So that is another 4, and next there are bottom unit cube is there. There are 4 side wall, and that 4 side wall 4 side atoms are there. So there is another 4. Total coordination number for FCC is 12. So this is the table for atomic packing fraction. I already discussed about these things, and what is the coordination numbers that also mentioned. Now this is the overall idea about today's topics. Thank you. So next we will discuss about the Miller planes or Miller index. What is Miller plane, what is Miller indices, and what is the interplanar spacing between two planes. That will be discussed in next lecture. Thank you.